world runs on data. Whether it's a database or your family pictures, the ability to save and retrieve data is a must for every application. Today we're going to look at the different ways to store files for Linux applications. The most common way to store data on a computer is to use a hard drive. Older hard drives were hard disk drives, or HDD. Hard disk drives would store data using a set of disk platters that spin around, storing data magnetically on the platters with a movable head that writes and retrieves magnetic images on the platters. Today, more often than not, you'll find what's called solid-state drives, or SSDs. These are integrated circuits that store data electronically with no moving parts. This makes them faster and more resilient than the older HDDs. Linux will handle HDD and SSD storage the same way. It really just depends on the connection method being used. There are three main types of drive connections used in Linux. The Parallel Advanced Technology Attachment, or PATA, connects drives using a parallel interface requiring a wide cable, and it supports up to 2 devices per adapter. The Serial Advanced Technology Attachment, or SATA, uses a serial interface which has much faster speed than a PATA, and it supports up to 4 devices per adapter. The Small Computer System Interface, or SCSI, connects drives using a parallel interface but with the speed of a SATA and supports up to 8 devices per adapter. When a drive is first connected to a Linux system, the kernel assigns it a file in the /dev folder. The file is called a raw device. It provides a path directly to the drive from the Linux system. So anything written to the file at /dev is also written to the drive. And anything reading the file reads directly from the drive. Added devices named this file /dev/hdx, where X represents the individual drive starting with the letter A up. Or SATA and SCSI uses /dev/sd. As you can see from the example on the screen, you have an SDA and an SDB located in the /dev folder. Most operating systems will allow you to partition a drive into multiple sections. A partition is a self-contained section within the drive that the operating system treats as a separate storage space. This can help you to better organize your data. For example, segmenting operating system data from user data. That way, if someone fills up the disk space with their data, the operating system will still have room to operate in the separate partition. The partitions are tracked by some type of index system on the drive. Older BIOS bootloaders use the MBR, or Master Boot Record method, for managing disk partitions. This supports up to 4 primary partitions on a drive. However, each primary partition can be split into multiple extended partitions. UEFI bootloader systems will use the GUID partition table, or GPT method. This is a more advanced way of managing partitions that support up to 128 partitions on a drive. Partition and numbers are assigned in the order that they appear in the system, starting with the number 1 and going up. Each separate disk partition will have its own /dev file. Linux attaches the partition number to the end of the device name and starts numbering primary partitions from 1. So on a SCSI drive, the first primary partition would be in the /dev/sda1 folder. In master boot record partitions, start numbering at number 5. So the first partition would be assigned the file name /dev/sda5. Linux typically detects drives and partitions at the boot and assigns each one a unique device file name. However, with flash drives becoming more popular and the ability to plug and unplug them while the system is running, this method needed to be modified some. And that's where the udev program running in the background came in place. Udev automatically detects new hardware connected to the running system. As you connect something such as a flash drive or an optical drive, udev will detect it and assign it a unique device file name in the /dev folder. Udev also creates persistent device files for storage devices. It uses the /dev/disk folder to create links to the /dev storage device files based on unique attributes of the drive. Udev creates 4 separate folders. You have the by ID folder, which links storage by their make, model, and serial number. You have the by label folder, which links storage by the label assigned to them. You have the by path folder, which links storage by the physical port that they are connected to, and you have the by UUID folder, which links storage by the 128-bit universally unique identifier assigned to it. After connecting a drive, you need to create partitions on it. There are several different tools for working with raw storage devices to create partitions. The following will cover the most popular tools. The fdisk utility is the most common command line partition tool. Fdisk allows you to create, view, delete, and modify partitions on any drive that uses the MBR method for indexing. You have to specify the drive device name and not the partition name of the device you want to work with. The example on your screen is from an Ubuntu server. Fdisk uses its own command line that allows you to submit commands to work with the drive partitions. Some common fdisk commands are on your screen there. So I'm going to pull up my Ubuntu server and show you what it looks like. So here I am in Ubuntu, and I'm going to do fdisk. I'm sorry, I got to do sudo fdisk, and we're going to do /dev/sda. And it's going to ask for my password. And then now I'm going to do the P command, which is going to show me what's available at the moment. And as you can see, my /dev/SDA is broken into 3 partitions. And I have the BIOS boot, and I have the EFI system, and I have the Linux file system at the side. One caveat about fdisk is that you cannot alter the size of an existing partition, but you can delete an existing partition and rebuild it. The key thing to remember is if you do any type of editing in fdisk, you need to use the W command to save the changes. The gdisk program is for drives that use the GPT indexing method. The gdisk command identifies the type of formatting used on the drive. If it doesn't currently use GPT, gdisk offers you the option to convert it. Now be extremely cautious when converting the drive method specified for your drive. The method must be compatible with your firmware, otherwise your drive will not be able to boot. Gdisk uses its own command prompt very similar to fdisk, as you can see on the screen, and it also has some similar commands that you can use. One cool feature of gdisk is the ability to use the -I command that displays more detailed information on partition, as you can see from this Ubuntu server. Let me pull it up for you real quick. Here I am back in Ubuntu, and you simply just use gdisk and then the file path instead of fdisk. And then once that comes up, I'm going to put in I so I can see more information. And it's going to ask which partition I want to look at. Let's look at the third one since it had more information on it. And there I see my GUID code associated with it, and then the unique GUID number, and it shows me the sector size as well. Another command line interface is the GNU parted method. With parted, you are allowed to modify existing partition sizes. So for example, you can shrink or grow partitions on the drive itself. For an example of the parted method, I went to my CentOS server, and so we are going to do sudo parted real quick, and then I'm going to tell it to print, and it's going to tell me what I currently have available, which isn't much on this very small cloud-based server that I have. In a desktop environment, you'll also have a graphical tool available for you known as the GNOME Partition Editor, or gparted. Gparted displays each drive one at a time, showing all the partitions on the drive. You can mount, unmount, format, delete, and resize simply by right-clicking the partition and going to the options for it. Alright, it's review question time, everybody. First, which type of storage device uses integrated circuits to store data with no moving parts? Second, what raw device file would Linux create for the second SCSI drive connected to the system? Pause and look back to the PowerPoint because we did mention both of these earlier. And here are your answers. Which type of storage device uses integrated circuits to store data with no moving parts? That'd be an SSD. What raw device file would Linux create for the second SCSI drive connected to the system? That'd be the /dev/sdb. Thank you everyone for joining me. Please come again.